Hello. After some trials and tribulations with the main streaming computer, we've managed to turn it off and back on, and I think audio is a little bit better now. So today we have a 1502 overhead. Yeah, today we have 1502, which I just opened. And I just disconnected a few things, and I don't really know what's wrong with it yet, other than it does not power on. So let's verify, and let's put our multimeter toggle on. Show yourself. Okay, cool. And so we don't have green light. We have very little power draw. There's not much happening. Yeah, so hopefully we'll figure it out. We're gonna troubleshoot it together, and let's see if it's fixable, and let's see if it's an absolute pain or if it's easy. All right. So let's find this T5. All right. Magnets. Of course, no magnets. All right. Well, no magnets today. MacBook. What board number is this? This is a 4924. 820 4924. So this is a 2015 A1502 with a no power problem. I am scared of what I'm going to see on the other side, and in case this is absolutely trashed on the other side, I have a relaxing connector replacement as a contingency plan. So we're gonna go from here. Get out of here, microphone. Boom. And then sneaky connector number 1. This is the connector you have to be very careful with. This is the camera connector. You rip that, you need a new screen assembly. Boom. Spoiler alert on what? There's no spoilers here. When you get your edited video spoon-fed to you, that's where you get spoilers. Symptoms, just no power. You plug it in, no green light, no power, no nothing. So, ooh, okay, very little corrosion. Ooh, this is gonna be fun. Nothing obvious. After doing this for a couple of years, if it's not obvious and it's more of a challenge, it's more fun usually. So let's see what we got and what we don't got. Okay. No power. All right, so let's take a couple of measurements, and let's go into the microscope, and we're going to find our not the pipe. We're going to find our PV-Buzz G3 hot fuse, and we're gonna plug in the laptop and see what we read on PV-Buzz G3 hot. Ooh, centered. Nice. Okay. Do we have a DC inboard from here? No, we don't. Let's use the customer's DC inboard. You know what? I'm not gonna troll myself. I'm gonna go grab a DC inboard. Alright, so I'm back. So as a precaution, I basically went ahead and grabbed myself a different DC inboard than the customers, because I've trolled myself way too many times when using the customer's DC in, and this one right here is mine and trusted, and I've ran a few laptops on it today. So let's just double check that it was not the DC inboard, and if it was, we're good. But clearly we're drawing the same amount of very little power. There's nothing going on, and let's take a couple of measurements real quick. Our first measurement that we're going to take is to check for PV-Buzz G3 hot. PCH is dead. Yeah, if the PCH is dead, you owe me a beer. All right. Oof, scratch. 0.6, so that looks like some sort of a diode voltage maybe, so this might be shorted. DCN is nominal, 18.2. PP342 is also kind of low. So, ouchie test. Well, it's been requested with an ouchie test, so maybe there's an owie test. Yeah, not sure. But, alright, so let's check this out. We have no PP342, no PPOSG3 hot. We only have DCN. And we're going to go around here. Let's go to the schematic. Actually, maybe, what could this be? Is this schematic and board view? So I'm thinking, since we have DC in with 18 volts over here, if this right here is 18 volts, because I just measured this at 18, therefore this resistor is working properly. We can double check that this is 68K to ground on DCN, because that's our charger detection right here. So let's do that real quick. Is it 68K? Is it 68K? $63, $68, $74, $5. Yeah, good enough. That sounds about right. Alright. But we don't have PP342G3 hot supply, because that's 1.2 volts over here. So we're going to look around this diode around D7005 and check out what is our situation in all three prongs. Let's check impedance to ground on DCN 64K, P-bus 500. Oh, that's 500K. I actually should put the microscope, shouldn't I? That's a scratchy. And here on this side we have 2.6K. Not great. Not amazing, not bad. So double checking this right now. So technically if we have 18 volts, we should get PP342, right? So let's check what gets to the PP342 regulator on this side. So we're gonna check pins 6, 8, 4, 2, and 1. And that's here. Right here. And so, boom, boom, boom. Let's see this. What are our in-out pins? Here we should have top of this resistor is capacitor 0. So here we should have something. We should have 18 volts. So we do have 18 volts going in on top of these three capacitors. So technically I have 18 volts here on these caps. Right? Yeah, correct. And then let's see. Oh, stop beeping. So we have 18 volts here. Now I'm thinking about what do we need to have here. The PP342G3 hot regulator, is that shorted to ground at all? Microscope. No, that's 3.8 kilo ohms. Okay. Fine. That should be more though. That should be a little bit more. Let's double check this resistor over here. If we have a shutdown pin, that's correct. So this resistor over here should be 0. Impedance across it. Is this a different board view? No. Oh no, here, this one. Should be 0. 0.8 ohms. Okay, cool. So this is getting its shutdown signal. Let's check the feedback resistors. The feedback resistors won't have anything crazy because they generate feedback from the 3.42 volts. Let's measure them anyway. So, top. That's 532. Well, okay. And bottom. That's 10K. Is the feedback messed up? I am measuring this in circuit, so this kind of is not accurate. So this top resistor, this should be 348, but we're measuring 500K, and this should be 200K, and we're measuring 10K. So either this capacitor is dead, or this resistor is messed up, or there's an internal short from feedback to thermal ground pad. 3 kilo ohms. I mean, you want more than 3 kilo ohms on a voltage line with an output and high current, like 342. I mean, it's not actually high current, it's 300 milliamps, but you should want a little bit more, maybe. I mean, at this point, I'm just tempted to take this off and see what's up. Let's actually, before we do all that stuff, let's just double check our board visually if we see anything absolutely obvious that is shorting us or messing us up. But I don't think I'm going to see anything constructive here. Okay. Okay. SMC looks fine. Fine. I don't like this 342 flux strip, but it looks factory as well. Alright, well, let's start with the IC and see what's going on here. Or this cap right here. This cap could also be an issue. So let's try this. Yeah, I'm thinking U7090. Feedback doesn't read correctly, and I'm having a fairly low impedance to ground on PP342. But we're actually going to risk it real quick because I don't like the way this cap here looks like. So let's see if I remove this capacitor, see what happens to our board. Let's take off this hard drive before we fry it. Alright, took off hard drive. Let's actually remeasure and see if we didn't get trolled by hard drive. Oh, did we get trolled by the hard drive? Oh, that's gonna be hilarious. No, still same symptoms. All right, U7090, you're out. You lost the game. Let's try this cap first. We dislike capacitors. Something fell. Okay. So we're just double checking for if the capacitor was at fault. I'm having kind of nightmares, bad dreams looking back to what this used to be before. Oh yeah, look at that. That was the capacitor. We blindly went for it, and that's it. That one cap was shorted. I claim no clairvoyance. That was kind of crazy. We have, believe it or not, fan spin fairly soon. So one bad ceramic cap is what was wrong with this board. And literally and figuratively sniped it. Sniped the board repair. Where did I put this cap? Okay, it's right here. Let's give it a little bit of a detailed look. I mean, I've seen too many of those fail in a similar way. Usually it's the capacitors on the other side. But we're still drawing 500 milliamp hours. Is there some sort of a crack in here I'm not seeing? Let's see. Milliamps, not milliamp hours. What's wrong with you? I don't know if this was a lucky guess or just sniped it. Well, let's see. Does this measure like a resistor now? This is a fairly common problem for 1502s in general. It's not this capacitor in particular that dies all the time. It is the capacitors on the other side. This does read open loop. And decreasing. Interesting. Now let's see if we can turn this board on again. Let's do twice to make it nice. Let's just double check. Maybe we just... Sometimes you heat something up on a board and you take another component off and it's... No, that was it. That was it. Wow. Well, the amp draw is kind of weird. I think it should be taking like 300 milliamps. Let's see if it has image. Let's double check that. Boom boom. Let's see how we can do in the image department. Okay. Come on, get out. Alright, so let's just do a preliminary turn on. Only screen and power. Okay. All right, so if we are lucky, we get question mark folder. If we are unlucky, we have a huge short on some line and a 500 milliamp draw. I think we have a short. Did that just leave magical smoke out? Was that magical smoke? Yep, that feels like magical smoke. How the hell would you have a 500 milliamp short? Well, it just killed my DCN board, so that's what magical smoke looks like. Let's see, magical smoke. Do we have backlight? Oh yeah, we do. Interesting. My DCN board diode might have died, but why? What would it cause it to die? What will cause it to die? Or what would cause the diode to burn while still turning on? I mean, we have question mark folder, which is a success, but I'm just kind of wondering, why did the DCN board get burned? I'm going to grab another DCN board, and we're going to check it out real quick. Let's see if we can kill another DCN board. All right, I grabbed 2 of Danny's DCN boards. Don't tell him if we kill both of them. We're about to double check if our laptop is a DCN board killer now. So, what explodes on these DCN boards is, let's see if we get a good view at it. All right, let's see if we can make this look up here. All right, so it usually blows on these DCN boards. How do I do this? Right here, yeah, is this diode. If I plug in this charger and this diode lights up, you know what? I'm gonna clean Lewis's freaking MagSafe too, because it's disgusting. That might just be it. So let's clean that out. Always turn your power off when you clean your MagSafe. You don't get this luxury if you're using an Apple charger when it's plugged in, but mine's plugged in, but I can turn the power off. So I guess unplug your charger if you're trying to clean your. Is that burned or? All right, hopefully. All right, I have 18 volts. I have a DCN board here, and we're gonna watch. Is that max zoom? That's max zoom. We're going to watch this diode over here and see if it dies. 3, 2, 1, go. Nope. Diode did not die. We're in a clear. Awesome. All right. So usually this guy right here would like explode in a fire. the customers, I think, is fine. If not, I'm giving them Daniels. Maybe that was the root of the issue. Yeah, that sparked. Interesting. Huh. Yeah. I guess not anymore. Yeah, I'm gonna switch this DC in board. This one seems to be better. But let's put that resistor back on. I mean, capacitor back on. Before we do anything, let's just put that back on. We took it off, so might as well. Grab a donor board. Do we have donors of this persuasion? We just might. That looks like a donor that I need. Yeah, okay, cool. All of those capacitors are missing on that donor board. Whoops. Ooh, more donors. Okay. Got it. All right, so let's do a quick switcheroo. Where are you? Here, this guy. Boom, boom. Exhaust on. Air on. Actually, let's prepare the pads before anything. Alright. Shit, we're out of shot. Damn it. Okay. One here. Some here. Solder. Good. So now we grab this guy. Take him off. Goat wick that you can get at store.rossmangroup.com, and Amtech Flux also at store.rossmangroup.com. Get yours today. Okay. So we're going to replace this capacitor over here. Pretty. So let's actually double check what the measurement was on PP3V42, or what it should be, rather. We had 3K before to ground, and now we should have more than 3K. Yeah, 200, 120, well, decreasing really. But if we tap it with the correct... I guess that wasn't a thing. How did I figure out that this is the cap? I don't know, it felt right. Still 2-3K to ground. Interesting. What about over here? Oh. Huh. Well. Intuition. See, like, this is what happens. That's my DCM board. So that's totally trashed. So I don't know why this board did that to my DCM. What you got on the other side? Well, same thing. It's a substrate with a bunch of legs to it. Interesting. See, but this is a healthy one here. And since it is healthy, we're going to plug it in. And I just want to do proof of concept. I want to prove that with that capacitor replaced, everything is fine and dandy. Yeah, we're looking okay. Let's do it a few times. Let's see. I'm just gonna go off, on. And off again. I guess we're fine. All right, well, cool. I'm happy. I'll take that. How long have we been on? 37 minutes? Oh, good enough. Good. All right. So we have successfully diagnosed and fixed an 1502 from 2015. This is an 820-4924 board. And what we had was an odd impedance to ground on PP3V42 and wrong output on PP3V42, even though the 18 volt input was correct. So what we diagnosed and what we looked at were these resistors over here. We double checked if this SHDN jumper resistor was measuring correctly, and it was. And what kind of tipped me off about this cap over here was a weird impedance between the spot and ground, but I was also measuring a lot more to ground than I should have been across. I mean, I was measuring across RA over here. I was measuring across R7095, and it was a lot more than it should have been. And also R7096 was also a lot less than what it should have been. Usually oddities in impedance are caused in capacitors acting erratically. They become diodes, they become resistive. Sometimes they even short. But we just took a stab at C7099, and that ended up being the issue. After removing this capacitor, the computer turned on. We did not have to take off U7090, so that was, call it skill, call it luck. We sniped it, a single component repair that, it also looked kind of sus. That capacitor looked, I don't know if it was a fracture, but it looked discolored for some reason. So maybe it wasn't broken all the way. Maybe it was, just internally messed up. But I think that's it for me today. That was a quick board repair. And thank you for watching. And I hope you learned something.